Hey, today we got a bit of geometry. I'll try to cover as much as I can with lesson 35. You might want to kind of skim through this too. Use this video as either an introduction or a review to supplement your reading of the book because there's a lot in there and I think it's good for you to read. But let me just hit some high points to hopefully make it a little simpler for you to demonstrate this so it's not just reading black and white print. When two shapes like a triangle and a triangle are similar, that means they look the same, maybe just different in that like one's large or like has been enlarged. Think of it as, triangle number 1 here was simply like we're looking through at a magnifying glass to see it in figure 2. It's the same one. They're just similar to each other. Okay? Maybe the sides aren't exactly the same, right? Like in this case, this side is one length, these sides are the other length, and then this side is a whole nother length, but let's use 4 now. These 4 tick mark sides are equal to each other in the same way that these 2 tick mark sides are equal to themselves. So like this might be 3 and this is 5, whereas these are 5 and this is 7, but it's similar. They're not exactly the same. They're like each other. They're similar, just like the way we use the word in real life. Similar doesn't mean exact, but it's a lot like it. Maybe it's just enlarged. Now, the thing about similar is it could just mean equal angles. That doesn't mean that they are exact, because this is a 45-degree angle, okay? This is a 45-degree angle, okay? And this is 90, obviously. Now, even though this is a bigger triangle, this can also be 45, and this can also be 45. And if that's the case, these are similar triangles. They're very alike. They're not exact, but if the angles are all the same, that's called angle by angle comparison, and if the angles all match, that means the sides are in proportion. Doesn't mean that they're necessarily the same, but they're in proportion. If I set up, these shorter sides to each other, they would equal the same relationship as these shorter sides related. Or even better, if I did this side over this side, 3 over 5, it would equal this side over this side, which is 3 over 5. It's a proportion that works. 5 over 3 would be the same as 7 over 5. Stuff like that. I think. I mean, I kind of made up these measures, so that might not be perfect, but we'll do some practice in the book. Congruent is not just similar, but that literally they are the same shape, even in measure, maybe just turned around. Let me show you what I mean. What if I have this triangle, and then I grab it, I copy, paste, and let's see if it lets me do this. I can just rotate it like that. Okay? Same triangle. I literally just did Control C and then Control V. Copied it and then pasted it. Do they look exactly the same? No. But they're more the same than this one. Than these ones were. Even though they're arranged different, oriented different, right? Because this one was flipped. It's the same measure, so they really are more alike. They are so alike, we call them congruent. It could be the exact same shape, just turned around, right? Congruent is the same. They have corresponding parts, like sides, this side, let's say it's 3, is the same as this side, which is 3. It just got moved over here, but they correspond. 3 and 3 prime or something. Maybe I should use letters, would be better. Let's call this side A, and this is A prime. Okay? I think about A and A prime very similarly because they are worth the same measure. And this is B and B prime. B and B prime. This one came second. There's a B and there's a B prime. They're very alike. And then there's C and C prime at the hypotenuse side. Okay? Congruent means like copy paste and then maybe just flipped around, you know, maybe it's that I grab it again and this one's congruent and I'm just going to try flipping it vertically. There it is. So it's just kind of mirrored now, but it's still congruent. And I can match up the sides, I can match up angles. Okay. There's this angle, and I know this should be the same angle, but let's go like this to show that you can do, instead of tick marks, with angles you can show angles like that. And what if I said, well, you know, there's this one, and this one. Those match up because the angle above the 90-degree angle was a single arc. And in this case, they both are. And then we have the double arc to the left of this right angle, which in this case is to the right because it's upside down. And those are both double angle. And by showing an angle instead of just with one arc, but with two, that means every time I show the angle with two in the given example, they're all the same.